Hello everyone. Today we are going to be discussing the matrix multiplication using three different types of techniques. So first is the MPI, which is like you are doing the distributed programming. I am going to be using Ubuntu for that, and one is serving as the master. So just the Ubuntu name is serving as the master, and I have a machine running in the background Ubuntu too, serving as the actually the slave. So let's run and the program, and then first is the MPI, then the second is MPI with the OpenMP. OpenMP is like for the threading part of it, and we don't have to do much into it. We just have to write the pragma command for that. It does it devices threads in number of chunks by itself. It is much more smarter than the pre-thread. And then I have the MPI plus the OpenCL. It's like the OpenCL is like you make your system much more better. Like you are using the processors, different types of processor combined together, like the GPU and the CPU. So much more better programming speed. It's for the execution speed. So let's run our code. I would be running the code sequentially. So not just that I mean that I am doing the code in sequence. I'm like I'll be running my sequential code, then the MPI code and all those sort of code so that I could do the analysis part and um giving different sorts of inputs so that like what happens if the matrix size is too small, what happens if the matrix size is too big, and all those sort of things. So let's run the first file. So first file would be my sequential file. Just dragging it here. So let's run the sequential file. It's here, executing that sequential file and, and giving the matrix size to be 100. Let's do the same for the MPI file. So I'm using the two hosts. So one would two processes. One would be for the master, and one would be for the slave. So let's do that. MP two five five, and the execution file name is MPI, and it's setting the input. So as you can see, it's much more faster. For even though for the smaller metrics, let's run the code for the other file. Let's okay, let's just change the MPI to OMP, and let's give the value to be 100. Now it seems to be like it's pretty much similar than the sequential one, even though slower, I would say, because the array metric size is too small. Let's run the same for the open CL and giving the matrix size to be 100. Now, when I was actually executing it once again for the demo video, I noticed one thing. When the internet connection isn't working properly, you won't be seeing any sort of output. So I switched to the Wi-Fi instead of using my own. So that does happen. Like it needs to be have a proper internet connection to actually operate onto it. So it seems like, oh my god, the OpenCL is slowest among them. But let's see, like the metric size is smaller, so let's uh, increase the metric size for each one of them. So again, the matrix, running the sequential. Let's increase the metric size to be 500. Okay, so it seems to be like it's working. Let's do the same with this one, MPI. It's literally half the time it took to do. Now let's do the MPI and give the metric size to be 500. Again, it's a little bit more than the MPI, but still the metric size is small that we are dealing with currently. Let's do with MPI. It seems to be working pretty faster. Now let's run it for the metric size 1000, because if I end up running it for 10,000, that would be a blunder, do the blunder for the stack. Okay, I have to run the metrics. 1000. It'll take a couple of seconds. So 2 seconds. Let's still have, let's doing it with the hybrid part and getting the value. Now it should be working faster as comparatively this one. Yes, it has reduced a little bit, as you can see. Let's do for the open here. Now, if you increase the metric size, as you can see, the distributed programming is working much more faster as compared with the sequential one. And we have the winner for MPI plus OpenCL. So that's how you do it. Thanks for watching the video.